Hello everyone and welcome back. We finally reached the near smart contract security section, and in this subsection we're going to be talking about access control issues such as missing access control, public callbacks, and much more. So see you in the slide deck. Alright, so let's begin. This issue is super basic. If you're familiar with Solidity, if you forget to put onlyOwner modifier, anyone can access this function on chain. Same example, missing access control. If we have super important function that we want to make sure only owner can access, we should always have an ownership check there through assert required, doesn't matter. Like for instance, there is example like we have possibility function and we have transfer function. So in this example, pause is not protected, so anyone can literally just post a contract, and if there is no unpause, it's just denial of service directly. So we always should have ownership checks on important function. Pretty simple. So like here we're asserting that owner equals to predecessor account ID, meaning that owner equals to the direct caller of that function. So yeah, that's pretty much it on missing access control. So let's move on. Incorrect near binding usage. So near binding macro is one of the most critical macros when we're developing near smart contracts, and it just behind the scenes generates necessary code to be a valid near contract and exposes intended functions to be callable on chain. So if we don't know what it does behind the scenes, it might introduce some super risky issues for us. Like for instance, in here, we usually put near binding on the top of the implementation of the contract. So like, let's say our contract is called status message, we have impulse status message, and we have near binding on the top. So we know that like those functions inside of the status message impulse are going to be exposed on chain unless they're specifically marked as private or we didn't put like a pub keyword. But sometimes if you don't know what it does and you think like, yeah, I guess I should put it everywhere just in case so it works. Like in this example, we have a possible trade, and here we're implementing possible for status message contract. And we put also near binding here. If we do cargo expand on this file, we'll be able to see that we're actually getting this toggle pause as public inside of impulse status message contract, and you'll be like, what? And it's actually super crucial to know. If we put near binding on implementation of a trade for current contract, every function inside of that trade implementation are going to be public. So toggle pause is going to be literally just made public and callable on chain. And we don't want that. So like in this scenario, even if I have a pausable function protected, anyone can just go here and call the toggle pause directly without actually bothering going through like access control checks. Like for instance, in here we have pause, and instead of calling pause with ownership check, malicious actor can just go and call pause from here to cause issues. So yeah, it's exactly the same thing that I explained before. We have just a contract like new get data and pub toggle pause. Pub toggle pause is protected. So we have ownership check in here, and then we have like possible implementation for a contract, and we have pause, unpause, but not pause, etc. And as I explained before, malicious actor can just go and call toggle pause and pause like any function inside of this block instead of just calling the protected one. So malicious actor can just bypass the ownership check by calling the toggle pause from here. So yeah, that's super important to know, and we should always be aware where we should be putting near binding in our contracts, or at least if we not sure, just do cargo expand and explore the code, just in case. All right, let's go to usage of signer account ID. So what's the difference between signer and predecessor? Predecessor is like direct caller of the contract, like just account calls this contract, and predecessor is going to be the account ID of the caller. In case of signer is a signer of the transaction, let's call it that way. So if we have like a contract A calling contract B and contract B is calling contract C, if signer account ID is used, in that scenario, like whoever called contract A is gonna be basically a signer of the whole transaction. So in case of, let's say, A calls B and B calls C, in the last step, predecessor is gonna be B contract, but the signer is gonna be person who called A contract. So the person who initiated the chain of transaction calls. So that's pretty much the difference. And because of this, we shouldn't be using signer account ID in access control, especially on super risky functions. Like just imagine we have some malicious actor with a phishing web page, and user, let's say user is super important admin or owner of super important contract, like a DeFi protocol, huge treasury, and they use like a signer account ID on treasury transfers, let's say. And in this scenario, since they're using signer account ID, that user can be tricked into sending all of the treasury money from DeFi protocols contract to malicious actors. So how it can be done? Hacker creates a phishing web page, user gets tricked into signing cross-chain transaction, and like user just looks and sees like, okay, this actually page calls this contract. This contract seems valid, why not? So the user signs the transaction gets executed, this contract gets called, but then that user did not explore it more in depth to see that this contract actually calls that contract, which is a rogue contract, which tries to do some bad stuff on our DeFi protocol's smart contract. So in this scenario, first contract gets called, and this contract gonna call the rogue contract, which gonna in return call the, I don't know, transfer all the funds function to hacker. And that's all basically. If that's because the signer account ID is used. If we look from the perspective of the victim contract during the ownership check, they're gonna see that the signer account ID actually belongs to this user, because that user initiated the cross-contract call. That's pretty much it. So we should always be super careful in that regard and not use signer account ID in our applications, especially on super important functions. Otherwise, if someone knows this, that user might be getting a lot of phishing emails to exploit the original contract. So like in this scenario, user gets tricked. That user signs a transaction to call this contract, but user does not see that this contract calls rogue contract, and rogue contract calls transfer all the funds from treasury to hacker. And that's only possible because this contract used signer account ID. So let's move to public callbacks. Also super simple as cross-chain calls. Callbacks should be accessible on-chain. And if we do not put any access control on callbacks, it's going to lead to basically exploitation of our contract. And we just have to ensure that the caller of a callback is the contract itself. And how it's done, it's just basically associating the current account ID with predecessor account ID. So the direct caller is the contract itself. Instead of you doing it manually, we can just private modifier, and private modifier behind the scenes, if we do cargo expand, is going to return this basically. So super easy. Just do not forget to put private modifier on your callbacks. Like for instance, in here we have resolve transfer, which gets called after fungible token transfer. And if we forget to put like private modifier in here, anyone can just call this function directly, and so accessible on chain because we have near binding here, as we explained way before in here. If we have near binding on trade implementations, those are going to be accessible on chain. If we don't have private modifier in here, anyone can call this function and just cause many issues. So that's pretty much it for public callbacks. And moving forward to lack of separation of privileges. It's bad for the centralization purposes and for risk management if one private key just rules the whole protocol. I imagine that user either loses a private key or that user leaks the private key like anywhere, like in a GitHub in one commit. And in that scenario, like the whole protocol can be compromised just because of one private key. And that's why, to prevent the whole centralization of privileges and to minimize the risk, like each protocol has to consider implementing role-based access control with a different, obviously different participant for each role. Otherwise, if we have one private key, but like in the code, we have a minter role, we have owner role, and we have, I don't know, manager role, but all of those roles are the same account ID. Obviously, it's not going to work. All the participants have to be different. So yeah, basically that's it for lack of separation of privileges. And yeah, in addition to this, if we want to harden it even further, each role must be governed by multisig with different participants set for each role, or protocol should have a role governed by DAO, which is responsible for crucial operations. That's ideal case, but at least let's implement role-based access control to minimize risk. So here is like just an example. We have blacklist account, owner is responsible for it. We have set price. Again, the owner is responsible for this. We have remove pool, and still owner is responsible for this. So if owner's key gets compromised, malicious actor can just execute all of those functions. But in this scenario, we have owner for responsible for blacklisting accounts, and in this scenario, Oracle responsible for set price, and we have manager responsible for remove pool. So let's say if Oracle's key gets compromised, malicious actor can only execute this function, but those functions are going to be safe. And to just get an idea how we can implement role-based access control, we can look at the access control Sol contract in OpenZeppelin. Those guys already like create pre-built contracts, so we can technically get an idea how those implemented and implement them ourselves in Rust and Near. And here the Near equivalent can be found here. Let me actually just zoom out so I can show it to you. Basically, there are two nice examples of this. One is this and RML, and there is also Near contract tools. I'll show you both of them in a second. Yeah, here we go. So let's start with this one. So I actually created that one. Just a TLDR. It's not done, it's not ready, it's not audited. Do not use it in production. As you can see, the last commit was 10 months ago, so it was mainly just to test how it can be implemented. It was like a my test for myself, and I just decided to add it to slides because I have a nice diagram in here how everything works, and it's based on access control solidity contract, so it might be a nice learning resource for you guys. And that's pretty much the reason I include it in here. I might actually, after I release this course, continue developing this further because I have some ideas how it can be improved. Like it doesn't have on access control, also has possible functionality. So yeah, why not? So, but for production stuff, I already seen some projects use it. You can use the Near SDK contract tools, and those guys have role-based access control implemented and many stuff. So if you want to use it in production, just use this one. And yeah, that's pretty much it. Just use this one. Do not attempt to use that one because it's not ready and it's not audited. But you can just check some tests. Like for instance, we have access control Near, and there is like expanded version because everything was built around macros. But if you want to see expanded version of role-based access control, it's pretty much here. Like we have add role, has role, check role, and a bunch of role functionality. All of them are based on the solidity contracts of OpenZeppelin. Add role, has role, check role. So you can see, maybe you can get an idea how to just, instead of using either of those contracts, but just code it yourself, like copy and paste that code. That's pretty much it for role-based access control. And I guess the next topic is denial of service. But before going there, let me go to a code to show you those examples in action and also show you how we can use workspaces RS to write integration tests and build POCs if we encounter exploitable contract, or just for your own project, so you can test some important cases and scenarios. All right, so see you in the code. All right, so welcome to the code. You'll have access to everything in here. Basically, I built different folders for each topic in Near security section, and this folder is called access control. And you'll have all the contracts, and we're gonna have a shared integration test file where everything related to exploiting all of those contracts is gonna be. So yeah, we're gonna have one integration test file with everything, and we have different folders with different contracts to exploit them. And we're gonna have build script so that you can just call build sh and build everything. So no worries about that. Okay, so let's start with access control issues and exploiting them. So we have just a basic victim contract, like a status message contract. We have data, post status, and owner. And we have like init, initializing, getting post status, get data, and get data is only available when contract is not post. And we have public toggle post, and it ensures that the caller is owner, and then we're only calling toggle post, and then we have set owner through signer account ID. And in here we have possible trait, and we have implementation of possible for status message. And here is the nearby again, meaning that unfortunately all of those functions are accessible on chain. In addition to this, as you saw, we also have in signer account IDs. Owner can be tricked to calling set owner and changing owner to a malicious actor, which is not good. So let's exploit those. So we're gonna start exploiting possible functionality. So in this scenario, we're gonna first, instead of actually calling pop toggle pause, which is protected, we're gonna call the pause directly in here to pause the contract. So let me just show you the integration test file using workspaces rs, and in here there are some other, as I told you, it's shared integration test files. So we have like in the future we're going to have race condition exploits, so those are like different contracts. Do not pay attention to them yet. So here are the contracts that we're going to be using. We have access control contract, exploit contract. All of them are going to be compiled to res folder through build script. No worries about that. Do not worry about that. So here is the like a preparation function. Just prepares all the contract, deploys contracts, initializes them, gives us like owner, caller, so that we can all use all of them inside of our exploit. So we have basically, we're initializing a sandbox workspace. We could have done testnet, but sandbox a lot faster. So we deploying access control contract, then we deploying the exploit contract. This one's going to be important when we are trying to trick owner. So owner calls exploit contract, and exploit contract calls the set owner method. So, and here we're just printing some data. Then we're also creating an owner, just creating random account, caller, random account. And here we're initializing the init, initializing the access control contract with init with some data, like owner is going to be owner ID, data is just hello world, and post status is false. So because it's so that it works. And we, yeah, here is the init function, so you can see all of the arguments match. And here we're printing everything, and then we're just returning a tuple with all of those, like with access control contract, exploit contract, owner, and caller. And now we basically, let me just move it here so it doesn't matter. And here is the access control. First, we basically just getting all of those guys from the prepare access control, and obviously since we're using async we have to await them, and since we're using anyhow we can use just question mark operator to propagate error to anyhow, so we're gonna just get errors easily. Okay, so let's first exploit incorrect nearby usage here. So we have just caller, just a random account, and that random account calls the access control contract. So ID is just gets ID of the contract, and we call pause here. Normally it shouldn't be accessible, but since we have nearby here, pause is accessible. So we can just use .call, then transact and await, and we're asserting that a result is success, and if it's not, we're gonna just print pause failed with some failures. So it gives us ID white failed, and then we're printing pause logs, so that we get logs like was paused or something else. And also we're getting post status by calling get post status from here. It should be here somewhere. Yeah, exactly. We're getting from get post status, and then we asserting that post status is true. And if it's true, all good. We pass the test. Actually, let me comment the second part out so it won't interfere. Like here. Okay. And now let me actually call the contract. Let me just clear everything. And let me just call it. Yeah. Okay, we call the contract and let's see what we get back. Running one test. Yeah, we get print lines with access control exploit contract deployed, access control contract deployed, and everything passed. So pause logs the system is paused, post status is true, and exploit works. So to see where it comes from, like victim contracts, when we call pause, we get like a log. Basically, we're just logging the system is paused, and we can see it from here. System is paused, and post status was turned to true from false, so everything works. We actually managed to bypass the ownership check inside of pop toggle pause. So let me just remove the nearby again and recompile the contract to see how it fails. Let me just recompile everything and restart the test. Now we should see some errors inside of our test, and our test should be failed. Okay, contracts are getting deployed. All right, as expected, our tests have failed. And let's see what we get back. Method not found. Yeah, that's because we don't have nearby again, so those methods are not available to be called on chain. So yeah, everything works as expected. And let's actually leave it like this, so we're actually fixing our contract along the way. So let's just clear everything and remove the terminal so it looks better. So now let's actually uncomment this part. So we have everything. In this scenario, what we're trying to do is to trick owner into calling exploit contract, so that exploit contract can call set owner and set caller, just a regular user, as an owner. So as you can see from here, set owner has ownership check, but they use signer account ID. So if owner gets tricked into initiating cross contract calls, we will manage to bypass this. So also I prepared an exploit contract. Exploit contract is super simple. We just have default like value. We don't need anything, to be honest. We just need exploit contract to call something else. So we have just exploit with address and with owner to which we want to set an owner in victim contract. So here we address to where we want to call it. We're using vulnerable contract, and here is the trait for it, like trait victim, X contract, vulnerable contract. And we're calling with some static gas, and then we're calling set owner with owner that we pass inside of argument, and then we're just resolving to get some like feedback, meaning that if exploit didn't work, we at least managed to fail our tests so that we won't get any false positive back. So here's the resolve exploit that just gets the result from a callback and returns boolean whether everything was okay or something went wrong. So here we are asserting whether result is error. If it's error, exploit is failed, and we just returning false. And otherwise everything was okay, and we're returning true. So yeah, pretty simple. We have exploit contract, owner calls this exploit contract, and exploit contract calls set owner inside of victim contract. And we managed to bypass everything because in this contract they use signer account ID. So let me move to integration tests. So in here, we already done this, and yeah, here we go. So we have owner. Let's assume we managed to trick an owner. So Because originally we won't be able to just take owner's account and call whatever we want to, but let's imagine we manage to trick an owner in calling our contract, so our exploit contract. So owner calls access control exploit and calls exploit function here, exploit function with address of access control account ID, so we're calling the victim contract, and with an owner which equals to caller ID, just a regular account. And then we're just asserting whether we got like true back or false back. If we got true back, all good. If we got false back, exploit failed. And then we're just printing some logs. And here is just another function to confirm that we actually managed to switch an owner, and we're going to call pub toggle pose. Pub toggle pose originally is protected by the ownership check through predecessor account ID, and if we manage to change an owner, regular caller will be able to call this function and unpause the contract, because like in the first scenario we paused the contract, and in this scenario we are trying to unpause the contract. So here we call the pub toggle pose and everything, and if everything worked, that means that we managed to change an account of an owner to a regular caller. And here we're just doing some asserts, and here we're getting pause status, and if pause status equals to false, all good, because we managed to unpause the contract from the first step. Okay, so let me run the test and see how it works. Actually, it's gonna, forgot. It's gonna fail because we actually fixed the contract. Let me just comment this part out. So it's gonna be like this. Let me comment this part out and change equals to true. We're gonna be pausing a contract actually in this scenario. Could not pause contract. Awesome. So yeah, now everything should work as expected. Okay, let's see. So getting deployed. Exploit succeeded, so apparently everything works. Yeah, everything is correct. So exploit succeeded and the system is paused, meaning that we managed to call pub toggle pause and pause the contract. And pause status is true. So everything worked as expected. So we managed to trick an owner into calling our exploit contract and just change the owner inside of victim contract to a caller. But yeah, that's pretty much it for this lecture, and I see you in the next one.